Okay, we're going to do some equation solving. We're going to build a little bit off of what we've already done in pre-algebra, which was using the additive inverse on some equations to help solve them. We're going to add to that a little bit and just try to really have a solid base foundation for how to solve 1-step, 2-step, and 3-step equations going forward. So let's start with just 1-step equations. Many of these first equations you'll be able to do in your head if you try by saying, in this case, what plus 7 equals 0? Because that's what r is. It's something we don't know right now. So what plus 7 equals 0? In your head, if you can think of that, that's great. If not, then we have these algebraic properties that we talked about that will help us to solve this. What we do is we look at what's next to r on the left side of the equation. We say, well, that's adding 7 to r. Let's do the opposite of adding 7. The opposite of adding 7 is to subtract 7. So we, on both sides of our equation, write a minus 7. I can write it here and write it here. And 0 minus 7 is just negative 7. So in this case, r equals negative 7. Now, it's not a bad idea for us to check our answers. And with equations, we can do that really easily. We're saying r is equal to 7, so put negative 7 where r is, and write your equation out, and then see if you get the same thing on both sides. We're basically saying, is this equal? Negative 7 plus 7 is 0. That equals 0. So, good job, us. Looks like we got it right. R equals negative 7. Let's do another one. This time we have negative 10 plus n. Now, if for whatever reason you would rather have this switched around, that is something you can do. We could write the n first and the negative 10 second. But either way, we should be looking at this and saying, okay, the thing that's on the same side is n, that negative 10. What I want to do is the opposite of that. So I want to add 10 to both sides if I'm using the algebraic properties to do this. So if I plus 10, that's going to give me negative 7. Now, we also could have gotten there, maybe mentally, with our mental math skills, by going negative 10 plus what equals negative 17 and trying to think through that question in our head. Now, let's check to see if we're right. Negative 10 plus negative 7 equals negative 17. Yep, that's true. That's negative 17 equals negative 17. So that's our answer here. Negative 11a equals negative 44. So here is something that we haven't done yet with pre-algebra math UC. This is actually what lesson 13 starts with, but lesson 13 has a lot of stuff in it, so I wanted to kind of break it down for us. So what's happening here is we're multiplying these together. Negative 11 times a equals negative 44. So we either need to think in our head, what times negative 11 gives me negative 44? Or we need to think, what's the opposite of multiplying by negative 11? And so that would mean that we would divide both sides by negative 11. So that means we get a equals 4. Let's check and see if that's right. Negative 11 times 4 equals negative 44. That's right. Negative 44 equals negative 44. Ta-da! We did it. Okay, this last one may look intimidating. It's not literally the last one. The last one for this set. This may look intimidating because we have a fraction. But remember that a fraction is just another way for us to write division. And in fact, we very rarely write the division symbol after pre-algebra. So algebra 1 and up. Most of the time if we're dividing, we just write it as a fraction because that's what a fraction is. So what we need to do here is think, if I'm doing v divided by 8, what's the opposite of that? Well, that would be multiplying by 8. And we can either do that as 8 over 1, or on the left side we don't really need the over 1 because we're just doing 8 times negative 5. What that does, and the reason we picked to do that, is it cancels out the 8. Just like when we learned how to multiply fractions together and learned that we could cancel like this. The good old days. So this is negative 40 equals v. Okay, we can check and see if that's right. And if we did this in our head, this would have been our thought process, right? What divided by 8 equals negative 5? Well, now we see negative 40 divided by 8 equals negative 5. So that is our answer. Now let's add a little step of complexity to this, because it's all fine and dandy when there's just one number on the same side as x to know what to do to get x by itself. But what if there's more than one thing? How do we decide which thing to do first? And there's actually kind of two answers to this. One answer is, if you do it right, it doesn't matter which way you do it, which is a really unhelpful sentence to have just said. I'm so sorry about that. What I mean by that is there is a way to do this that we just tend to be better at, and that's what I'm going to show you, is the thought process there. Because technically we can move the 3 first or the 1 first and get the right answer. There's just one of those is an easier situation to do. So the way I think of it is, in an equation when we're solving, we're trying to undo the things that are happening to our variable, in this case b. So what's happening to b? Right now we have it being divided by 3, and we also have it being added by 1. And if we think about it, if we knew what b was, which of those things would we do first, right? If we knew b, we'd divide it by 3 first, because that's right next to b, and then we'd add 1 to that answer. So in an equation, because we're trying to undo that, we are going to go backwards. So I'm not going to mess with the 3 first, I'm going to mess with the 1 first by subtracting 1 from both sides. So b over 3 equals negative 4 plus negative 1, which is negative 5. So then we're ready to say, okay, now what do I do with this 3 on bottom? b divided by 3, the opposite of that is multiply by 3. So those 3's cancel, and b equals negative 15. We can check our answer. We can say negative 15 divided by 3 plus 1. Does that really give me negative 4? So we start off by dividing. We divide before we add, which the way this is written, hopefully that's the way that you thought we should do it anyway. It's like we're simplifying the fraction first and then adding. So that's negative 5 plus 1, which is negative 4. So yes, negative 4 is the right answer. Alright, we've got another one that has kind of a similar set of things to think about. Except these are both negative 4, so that's going to make things a little tricky. If I think about the order, if I knew what n was, the order I would do this, I'd multiply by negative 4 first, and then I'd mess with this negative 4 that's over here on the left. So because we're undoing this, we're going to add 4. I'm going to erase these so they don't look like division. I'm going to add 4 to both sides, and make sure you add on the other side of the equal sign. When I'm saying both sides, we have a left side of the equal sign, we have the left side of the equal sign and we have the right side of the equal sign. So when I add 4, it doesn't add with the negative 4, and it doesn't change that because it just takes away that negative 4 that we didn't want there. And then we say that equals 16 plus 4, which is 20. Now I'm going to move the negative 4. I'm going to get rid of that by dividing both sides by negative 4. So n equals negative 5. And that's my answer. Let's check it. So negative 4 times negative 5 is a positive 20. Negative 4 plus 20 is 16. So 16 equals 16. That's our answer. I mean, that means that negative 5 is the right answer. Sorry, I got distracted. Okay. Negative 2 plus 5m equals 78. That's actually super similar to the one we just did. So you might pause the video and see if you can do this one on your own and then start it back up either when you get an answer or when you get stuck. So we're going to move the negative 2 first. Always save what's right next to the letter, either even with it here, this 5m, or like if it's a fraction. Always save that for last. So we're going to add or subtract first. In this case, add 2. We get 5m equals 80. Then we're going to divide both sides by 5. That should pretty much always be your last step, is the dividing by or multiplying by something. 80 divided by 5, what? That's not a part of my multiplication tables. 5 goes into 8 once, with 3 left over. 5 goes into 36 times, so m is 16. Do you think we're right? The thing with checking on a problem like this, hopefully 5 times 16 is 80. If we got the division wrong, we're not likely to get this multiplication right all of a sudden. Maybe I'm just being cynical, but for me at least, if I made the mistake in the division, I don't feel confident that I would have noticed the mistake in my multiplication. Maybe I would have, but don't feel super confident about it. But 16 is the correct answer. Now, what about when we have a variable on both sides? So when we did lesson 9 for Math UC and had our problems with the additive inverse, we actually did problems where there were variables on both sides. And so the same thing is going to happen here that happened in lesson 9, except we're going to end up with an extra step because those problems were created a certain way to make them easier. So here what we've got is an n on each side and a number on each side. We want to kind of like separate them so the n's are together, the numbers are together. So it doesn't matter which way you move n, we generally will try to move it so that we get a positive answer instead of a negative answer, just because we like dealing with positives more than negatives. So that would mean that I would add n to both sides. So the 1 doesn't change. 2n plus n is like 2n plus 1n, which is 3n, and then the negative 14 is all that's left on the right side. So now it's actually like what we just did a second ago. I'm going to take the 1 and move it over, so subtract 1, and get 3n equals negative 15, and then I'm going to divide both sides by 3, and get n equals negative 5. Now when I plug this in, I have to plug it in on both sides of the equation. So over here and over here. So 2 times negative 5 is negative 10. 1 plus negative 10 is negative 9. Here we have 2 negatives that would make this be actually a plus 5. Negative 14 plus 5 is negative 9. So yes, looks like negative 5 really is our answer. Let's do another one. So here we've got n's again, but this time if I move the 3n over to the left, I have to subtract it. I'm going to get a negative number. And that's fine. I can do that if I want to. I should still get the same answer. But like I said, most people will purposefully do it so that we get a positive n, just to make there be one less negative in our lives, which is nice. So I'm going to add n over and get 7 equals negative 1. 3n plus n is 4n. And then I'm going to add 1 to both sides and get 8, because remember we're trying to just move this stuff away from n. And now I've got 8 equals 4n, so I'm going to divide both sides by 4. So that means that n equals 2. And I have this as 2 equals n. That's the same, by the way, as n equals 2, because there's a property for equations that you can just switch the sides as long as you don't change anything else about them. So in case you were wondering about that, yeah, it's the same thing. Now, is this the correct answer? 7 minus 2 is 5. We'd have to do 3 times 2 and get 6. Negative 1 plus 6 is, in fact, 5. So, yep, looks like we got it. Alright, 4m plus 5 equals 6m minus 7. Again, if you feel like you are getting the hang of this, you should totally try it on your own and then check back in. I'm going to subtract 4m from both sides and get 5 equals 2m minus 7. Now I'm going to move the -7 over to the left because I want to get m by itself, and right now m is on the right. So add 7, get 12 equals 2m, and now I will finish by dividing by 2. 12 divided by 2 is 6, so our answer is 6. 4 times 6 plus 5, 6 times 6 minus 7. This would be 24 plus 5. This would be 36 minus 7. Both of those are 29. So that is the correct answer. Thanks so much for watching. I will leave some links in the description where you can see some more resources on my website for solving equations, including some really cool practice applications that give you lots of problems you can practice and the right answers to them as well. Thanks for watching, and I'll see you in the next video. Bye.